Hi, everybody. So we are going over 8.1 notes, matter and temperature. I think almost all of you have started this, but we're going to redo it just because it's been a few weeks since we've looked at it. So the nature of matter is what we're looking at. We want to talk about temperature and we want to talk about matter, but we need to first understand what matter is, and then this section itself is a lot of vocab. Your essential question: how can we classify matter? And essentially, what we're doing here with all this is just taking a look at different vocab words and making sure that we understand the difference between them, the relationship between atoms and elements, molecules and compounds, pure substance, whether it's an element or a compound at the molecular level. So we need to be able to look at those. Look and determine if it's a pure substance or a mixture, and then if it is a mixture, is it homogeneous or is it heterogeneous? Matter, made of tiny particles in constant motion. Matter, anything that has mass and takes up space. Pretty much everything, but not everything. When I say pretty much everything, if you can touch it, you can feel it. Things that have mass take up space. Things that aren't matter would be the light that fills your room, the energy, the heat that you get from a fire, the things like that. That's what matter is not. Okay, and there are other things too, more abstract things, ideas, concepts, whatever. Those are thoughts. Like those are things that aren't matter. But right now I'm sitting on a bed in a quiet room doing this. The bed that I'm on is matter. The air that I'm breathing in is matter. Matter starts early on. So looking at two guys, Democritus and Leucippus, and I could totally be butchering those names. I do not know for sure. Propose that matter is made up of tiny particles called atoms. So if you think about this, we're talking like way back when people had one name, Democritus, Leucippus, right? They were philosophers. We didn't. Science wasn't necessarily a thing. It was philosophy. And these atoms were this idea that very few people believed in, because basically what they're saying is that, okay, the this gold coin that I have isn't made of just like a chunk of gold. It is made of tiny, tiny little particles called gold atoms. And what they're saying is that eventually, if I were to cut this piece of gold in half and in half and in half and in half, eventually I'd get to a point where I can't cut it anymore. And that's what they're saying an atom is. There's tiny little particles that make up this chunk. Instead of it just being a chunk, they thought it was made up of tiny little pieces. Robert Brown was the guy that first provided evidence for this. Okay, atoms weren't highly believed in, and this guy comes around and he notices that in that chunk there are little particles that are actually moving independent of one another. This jerky motion, he calls it Brownian motion, and that's kind of described here. Tire tube, foam cup. We throw a marble at a tire tube. It's going to move a little bit, but not a lot. We throw it at that foam cup. That's that jerky motion that we're referring to, that jerky motion called Brownian motion. So that was our first evidence for atoms making up matter instead of it just being a chunk of something. So now let's look at the different forms of matter that we can have. So the first learning target that we had was atoms versus elements, right? So let's look at what an element is. And an element is going to be, you guys have all seen a periodic table of elements. And there's all kinds of different elements listed, but an element is a pure substance. It's not made of other substances. It's not made of other elements coming together. An element is a pure substance. Aluminum foil is your picture there. That is made of aluminum atoms. A pure substance cannot be broken down into other substances by chemical or physical means. It is that substance. Aluminum is aluminum. Gold is gold. Oxygen is oxygen. All the matter you are ever likely to experience is made from one or more elements in nature. Water would be an example, not of an element, but an example of something made of elements, right? And water is a compound, so water can be broken down into its elements, hydrogen and oxygen. When we talk about elements, we're not talking about like water, earth, wind, fire. Those aren't the elements we're referring to. We're referring to the periodic table: hydrogen, oxygen, helium, whatever. You guys get it? You've seen them. Now, an atom is the smallest particle of that element, the smallest particle that retains the chemical identity of the element. So if I'd already kind of mentioned this, I have a gold coin and I would cut it and cut it and cut it and cut it and cut it. Eventually I would get to a piece that's too small for me to cut and still have gold. Okay, we can split an atom, but I no longer have that element now. So an atom is the smallest piece of an element that you can have, is one little atom. A gold coin is made of billions of gold atoms put together. Um, So that's an atom. The term atom literally means uncuttable. That's what it refers to. It refers to the smallest piece of something that we are not able to cut anymore. We are not able to break it into other. We are not able to break it and yet it still be gold. Atoms are all different. Different elements are different, have different atoms. Carbon atoms are going to be different than sodium or aluminum and oxygen. They're going to have different sizes, different masses, different properties of them. Okay, so atoms of different elements are different. Not all atoms are the same. Gold atoms are not the same as silver atoms. Now, next learning target was compounds and elements. A compound is two or more different elements chemically bonded together. So, like water was our example before. Water we know is made of hydrogen and oxygen. That is a compound. Hydrogen and oxygen are chemically bonded together. There are chemical bonds that actually hold those atoms in together to make a compound. Oh, there's a ton of compounds. Propane is one. So if anybody started up their gas grill, which I'm sure many of you guys have, okay, propane would be an example of a compound. Water, of course, carbon dioxide, and there's so many more. Table salt, sodium chloride, glucose, C6H12O6 is made of these different. So there's a lot of different compounds that we could have, and you guys are familiar with a lot of them, whether you know it or not. Compounds contain two or more elements, and those are different than molecules. Okay, so a compound versus a molecule. A molecule is a group of two or more atoms. Compounds, I'm going to go back a couple slides here. Compounds are two or more elements, okay, while a molecule is two or more atoms. Specifically here, let's look at the oxygen that we breathe in. It's not just one oxygen atom, it's O2. That would not be a compound because it's two of the same element, right? So two atoms, yes, but they're the same element. It's not a compound. But that O2 would be considered a molecule. So a molecule is a group of two or more atoms joined together chemically. Anytime we have more than two or more atoms together chemically, it's a molecule. When those elements are different, then it becomes a compound as well. Matter can be divided into two categories, and that's big. So if we were to look at something and we say, okay, I want to classify this piece of matter, that matter is going to be broken down into either a pure substance or a mixture. That's the first split that we have, right? So this is kind of looking at that next learning target then, pure substances versus mixtures. A pure substance is what we've talked about so far, something that cannot be broken down physically, something that is chemically bonded together, or it's just that atom. So elements are pure substances, compounds are pure substances, molecules pure substances. They're chemically bonded together, or it is just that element, and it's not made of something else. Okay, so pure substance cannot be separated into different kinds of matter by physical means, such as sorting, filtering, heating, or cooling. Um, an example of that would be if I have water, I can't put it through a filter or just let it sit and separate out or boil it and it not be water. Okay, even if I boil water, it still is water. It just is now water vapor. It's water gas, right? So I can't separate out that hydrogen and the oxygen physically. I need to do that chemically. If I were to separate out the hydrogen and the oxygen, I need to hook it up to some electricity, and then I can separate out that hydrogen and the oxygen. But that is a chemical change and not a physical change. There's a chemical reaction that's occurring there. So the pure substances cannot be broken down physically. We need to change them chemically. Mixtures can be broken down or changed, separated physically. Think of like Kool-Aid. Kool-Aid, I can boil off the water molecules and I can be left with sugar and some red stuff, right? So a mixture is something that can be separated physically. Many substances you encounter are mixtures, different elements and compounds put together. That's what mixtures are. So in this picture here, you can see that we have some single brown atoms not connected to anything. Those would be your atoms. You can see some compounds there where we have a green and two yellows. That green would be our oxygen and the two yellows would be our hydrogen. Okay, so that would be a water molecule. Two hydrogens, one oxygen, H2O. So we have a few water molecules in there as well. And then we have some other compounds or other molecules there that are all those combined, carbon, hydrogen, and oxygen all combined. So just looking at those, you can see some different. This would be a mixture because we have different substances combined, but not chemically combined. We have atoms, we have compounds, not together chemically, but just in the same grouping. All mixtures share one common property, that they can be physically separated. The blood is an example there. If anybody has heard of people donating plasma, you guys haven't yet because you're not old enough. But if you know of anyone who's donated plasma, they take out your blood and they separate. Your blood is not just red blood cells. They separate the red blood cells from the rest of your blood, the water, the proteins, the white blood cells, things like that. And they put the red blood cells back in you, and the plasma then is that other stuff that's in the blood. So they can use a centrifuge and they spin that blood to separate it out physically. So your blood is a mixture of different things. And when you donate plasma, you are giving everything else, not the red blood cells. Now we can break down mixtures into two things as well, two categories: homogeneous mixtures versus heterogeneous mixtures. Homogeneous mixtures, they are the same composition throughout. So that is going to be like, the example here is a candlestick. Is most brass is made of 70% copper, 30% zinc. Kool-Aid, shouldn't matter if you have the first sip of Kool-Aid or the last sip of Kool-Aid. If it's well mixed, it should taste the same. Gatorade, same thing. Okay, those are mixtures that are the same consistency throughout, the same ratios of those molecules, of those substances throughout the entire mixture. It doesn't matter if you cut the brass candlestick into 10 pieces, each piece would contain the same percentage of copper and zinc. Versus a heterogeneous mixture, those, that would be like chicken noodle soup or a chocolate chip cookie or Lucky Charms. If I'm eating Lucky Charms, sometimes I get a bite or a spoonful that has a whole bunch of marshmallows, and sometimes I get those cardboard pieces that taste like cardboard that my son, my 2-year-old, won't eat. That's a heterogeneous mixture. Not every bite is the same. They're not mixed evenly throughout. Um, so that's what a heterogeneous mixture is. Different samples are not necessarily made up of exactly the same proportions of matter. One spoonful of chicken soup might contain both broth, noodles, and chicken, while another might just be only broth, right? So it's not the same composition throughout, and that's a homogeneous versus heterogeneous mixture. I'm not going to do this slide. I'm going to skip that one. Thank you for listening.